Thank you very much for having me here at this workshop. So I need to start with a caveat that I'm a computer scientist. I'm not trained in law, but I've been working at the intersection of AI and law for over 20 years. So I work with law professors, I work with law firms, I work with policy people, but I don't have that training in law, so please show mercy on me on that part. So what I'm going to be talking about today is research that has been going on in the AI and law community, which very much starts with the AI. I'm going to be speaking about some of my own research and the research that other people have been doing in this area as well, some of which has just been presented very recently at the International Conference on AI and Law that was held in Chicago in June that Dan Lima hosted, who'll be speaking later on. So a lot of this is fresh off the press, as well as some historic work that has been going on in the area. Okay, so this is the motivation for the research that I do, and it's very much coming from a computer science perspective. So I'm interested in the question of whether we can automate the reasoning that's undertaken in legal cases using AI techniques. And the key word to focus on there is reasoning. So there's a lot of work that has been going on in the AI and law literature that is not necessarily capturing the legal reasoning, and I'm starting with that question. And of course, we want to make sure that we can do this in a trustworthy manner if we're going to be able to get this research deployed in practice. So how do we go about tackling this problem? Well, it's not just one question. You can break it down into a lot of different sub-questions, and there are different people working in the AI and law community who work on different parts of this challenge. So here's just a few of the key tasks that are involved. So first of all, we need to be able to accurately capture the legal reasoning in the AI models. A lot of that is what we would traditionally call the knowledge acquisition task. So it's not just the data, but it's actually the reasoning that is undertaken with that data. And we need to build models for the future, but there's the problem that we're always using past data, and we know that new legal questions are going to arise. So when those questions arise, are we able to rely on that past data for dealing with new problems in those gaps? We need to identify relevant precedent cases and how they link to current cases. Everybody knows there's a lot of work that goes on processing natural language source text. How do we translate those into formal computational models and do that in an accurate manner so that it retains the essence of what is being expressed in those texts? There's a lot of interpretation, subjectivity in law. How do we produce those different interpretations with these computational models? And how do we do that in a way that makes sure that the outputs are scrutable and the explanations are understandable to the end users in terms that they would recognize? Of course, there's a lot of evaluation work that has to go on in terms of how accurate the tools perform these tasks. And it's also been pointed out to me very often as well that we need to capture non-textual inputs into the decision-making. One of the criticisms that I've seen leveraged at a lot of the work on AI and law is that, okay, we're just dealing with the source text, but there's a lot of contextual information, perhaps in the political situation that goes on that isn't necessarily expressed directly within the text that are being used to train some of these models. So that's not meant to be an exhaustive list, but it's just meant to give a flavor of the different technical challenges that are involved when we direct AI at this task of modeling legal reasoning. Okay, so when the chatbots all hit, of course, everybody said straight away, can the LLMs perform well at this particular task? We've had a proliferation of papers where people have looked at a range of LLMs and said, how well do they do at performing this particular task? There's loads of research that has been published on this, and I would contend that the large language models cannot perform all of these tasks to a consistent high level of competence. Sure, they can be directed at some of these tasks, and they can perform very well at some of them, but not all of them. So the main thrust of what this presentation is about is that I think we need to look at a variety of different AI techniques and direct the most appropriate techniques at different parts of the problem of modeling legal reasoning. Okay, so the idea of building data-driven predictive systems for legal applications existed before generative AI hit the headlines. Lots of machine learning approaches for what is known as the legal judgment prediction problem have been popularized in recent times. There's individual papers that have been published on this. There's been some work that has been reviewing this. This is a paper that was published in the AI and Law Journal that did a little bit of a reflection piece on these, that looked at how we think about automatic prediction of court decisions and looked at how we can categorize the work that has been done so far, looking at whether we can just replicate what has gone on in... Okay, so let me carry on. So this is a paper that I would recommend looking at that reflects on that issue of what counts as legal judgment prediction. Are we just trying to replicate what came in the past, or can we actually forecast the outcomes with these AI tools? And a lot of the work reported has varying success rates on that accuracy question, and it's quite often, if we train our AI model and if we look at past cases that have already been decided, what's the accuracy of our AI tool in matching the decisions in past cases? And there's varied different accuracy metrics reported from 70% upwards. But a big issue as well is the explainability of the outcomes of these legal judgment prediction tools. So in the early days, what was often done was a list of frequent, highly weighted words were given when presenting the outcomes. But if you look at some of those early papers and you inspect those lists of words, a lot of them were actually irrelevant to the decision-making that formed part of the judge's reasoning in the outcome. So I would contend that these are not law-following. If you just say, these are the data points that were highly weighted in terms of the outcomes, that's not how a human justifies their decision when they do this. So we've got an issue there already with this law-following idea. And in the early days of this work on legal judgment prediction, explanation was often overlooked. One set of techniques that can help with this is something from the field of computational models of argument. This is a whole subfield within AI. A lot of it is directed at law, but not specifically at law. It's applied in other fields as well. So doing some reflections on this work from recent years, I want to highlight some comments that some people from the AI and law community have made on this. So Henry Pracken, who works in the AI and law community, he gave the keynote talk at the Jurix 2024 conference in December last year. And he was reflecting on the legal judgment prediction questions and stated that prediction is not decision-making, and this is a problem for some of the developments in AI and law. Judges don't undertake the task of predicting, they decide on cases and they justify their decisions, not with statistical correlations, but on legal grounds. So here, I want to just mention some work that has been done in the fields of computational models of argument that do aim at capturing reasoning and providing explanations. So argumentation, as we understand it from the philosophy literature, is about the exchange of arguments concerning matters of what to believe or what to do and a justification for that. And the field of computational models of arguments aims to capture debates that involve competing arguments, and we identify what the arguments are, which arguments attack one another, which arguments defeat which others, and which are able to defend themselves from attack, and do this in computational models. And there are applications in a number of domains. It's not one technique, it's a whole range of different techniques. You have structured argumentation techniques. One key model is the aspect plus model for doing this, where there are arguments identified, sub-arguments, and the attack relations between them, all the way up to what we call abstract argumentation frameworks. This is what computer scientists like to deal with. We understand graphs, nodes, and edges between them. So can we model debates as these arguments? The way you read that graph is that we've got arguments A, B, C, D, and E in this debate. B attacks A, C and D both attack B, and they attack one another. E has no attackers, nor does it attack anything. And then you can run algorithms over these to decide which arguments it's acceptable and consistent to believe together. So some work that we've done on Liverpool in this vein is we developed something called the angelic methodology, and it was to design systems to reason with legal cases using these computational models of argument. There were 3 iterated phases that we worked through. So you analyze a domain to extract the legal factors. We've done some implementation of this once we've built up the hierarchy of factors in the domain, and then we evaluate it by looking again at past cases and seeing whether our tools can come up with the same answers that were come up with in past cases. So we've got formal definitions for all of these. I'm not going to go into those details here, but that's what these essentially look like. We've got these statements here, and we want to know whether one particular node in one of the graphs is acceptable or not, and that depends upon the status of the children. And each of these nodes map on to legal factors within a specific domain. So we have to build these graphs for each of the scope domains that we look at. We evaluated this methodology on some well-known data sets. One that's been studied in the AI and law literature for a long time is trade secret misappropriation. There is another set of cases called the wild animals cases that are all about possession. And we built, this is what our abstract model looks like, but it's been instantiated in the wild animals domain. And there are these famous cases that have been decided under this domain. So one is about the recipe for KFC. So somebody said, KFC said somebody stole the recipe for their fried chicken. That was a trade secret misappropriation. The wild animal cases about what it means to capture an animal that is being hunted or pursued. It might be fish in the sea, it might be fox. There's a really famous case, Pearson versus Post, of a fox being pursued and wounded, but not in someone's hands, so did that count as possession or not? And we also looked at cases that involve looking at different values, whether how you balance privacy and exigency in cases where you've got warrantless search is the question. So you must have a warrant to search somebody's home, but does that apply when they've got, say, a motorhome and that can be driven away? So we evaluated our approach on these 3 different domains, and then after that we worked with a law firm in the UK to model 4 different domains and evaluate the methodology with them, and that worked out very successfully as well. And what we've moved on to most recently is the European Court of Human Rights, because there's lots of data available in that. So the most popular article in the European Convention of Human Rights where people make submissions to is under Article 6, and that's guaranteeing the right to a fair trial. This is the statement of that from the European Court of Human Rights webpage. And there's this guidance document on Article 6 that's 115 pages long. So if we're to build a model of Article 6, we had to look at that, and we've had to look at the law, and we've had to consult with professors who are experts on that law as well. And the motivation here is that there are over 60,000 applications pending in 2024. So we're interested in looking at whether we can build decision support tools that could help with some part of the process in dealing with these cases. Not replicating the judges and taking them out of the picture, but it might be something like triaging cases in the first instance. 95% of the cases that are submitted are deemed to be inadmissible. So even building a tool that could perform some kind of admissibility check on cases when they first come in could help speed up with the processing of those cases. So because of the availability of data from the HUDOC database that is made available by the European Court of Human Rights, this has become a really ripe area for people to build and test their AI tools. Here's one of the first papers that did this. This was published in 2016 on predicting judicial decisions using a natural language processing perspective. And there's been later work done as well. So a few years later came this other paper that was published in the AI and Law Journal. So we used this domain as well to look at whether we could model Article 6 in this computational model of argument that we've built, and we aim to capture the legal knowledge within that domain. This is the abstract version of what it looks like, but it's drilled down into the detail of the specific legal factors, and we then turned it into an executable program. So what we subsequently started looking at was where we could use machine learning and how to point it at the most appropriate parts of this task. And we looked at whether machine learning could be used to determine which parts of the model apply to specific cases now that we've built this symbolic model that gives us these nice explainable outcomes. So because we've got a symbolic representation that supports a step-by-step justification of each node in terms of its children, and the explanation can be visual or it can be text-based, and it can be customized to particular parts of the case by drawing attention to the legal factors on which the individual cases were contested. And we can also unfold the reasoning steps as well. We can look at what the backing was for each of the different steps and how they're justified by referencing precedent cases or other statutory references. So if you're interested in looking at the details of that, we published this in the Artificial Intelligence Journal and focused on the explainability of the tools that we produced. So just to give you a flavor of what these explanations look like, This is the outcome from our tool. This is just one snippet from one particular case. So we can see here that it's explaining in very clear, understandable terms what the reasoning is. This just relates to the nodes that are being traversed in that graph as the reasoning algorithms proceed over those. So we've got the conclusion that the applicant was a victim. The case was well-founded because it examines a fundamental part of the Human Rights Act, and the domestic courts have been exhausted. So each of these points relates to nodes in the graph, and we can just see what the outcome was of the reasoning over those different nodes. Okay, but because it's a symbolic model, we do have the drawback that a lot of these symbolic and rule-based approaches suffer from in terms of the knowledge acquisition bottleneck. We have to be able to get that legal knowledge captured in the symbolic model in the first place. But in the experiments that we did with the law firms who we worked with at doing this, they benchmarked this and the time that it took to build the symbolic models, and they felt that it wasn't prohibitive because once you've captured the reasoning in that particular domain, we're able to verify quite easily whether it's doing correct reasoning, and then we can get a number of cases put through the system, and we can see these explanations, and they're much more trustworthy for being able to produce these explanations. So it wasn't felt to be a blocker building the symbolic model in the first place. But what I'm really interested in working at, and what a lot of other people in the AI and law community are looking at now, is hybrid approaches that merge the benefits of building symbolic models and data-driven approaches as well. So using these symbolic models allows us to encode the legal reasoning and provide explainable decisions, but I acknowledge significant effort is needed for doing that manual analysis of cases into factors for constructing the case base and representing those use cases. So here's where we see a key role for machine learning for helping us with the task of what we call factor ascription to the model. And we've published this at the EURIX 2022 conference and have done some work on that since that to expand our model. So that's the approach that we take, but others in the AI law community are advocating for this as well. There was a talk that was recently given by Bart Verheij from the University of Groningen, who also works in this space. And when he was president of the International Association for AI and Law, at the conference he gave his address where he talked about where he thinks we can move in future with merging these AI techniques into these hybrid systems. We started in the 1950s with intelligence systems. There was the boom in knowledge-based systems in the 70s and 80s. Then we very much went to a data-driven approach in the 2000s. And he thinks that these can be merged, and argumentation systems are a way to be able to do this moving forward. Okay, so I will finish up by saying something about evaluation of these different approaches. So we are getting more shared data sets that are being used by multiple people to evaluate the different techniques that they're coming up with. We now have competitions to try and help with some standardization and some benchmarking for this. The colleague competition is one that's now well established for evaluating legal information extraction and textual entailment techniques. Results of this are generally reported at the International Conference on AI and Law. So you can see the results of the latest competition that was run at that webpage there. If you just do a Google search on that, you'll see the results that were just presented in June this year at ICAL in Chicago. But I also want to mention caution that is being urged on the pitfalls of treating judicial opinions as data sources, which is what is happening with a lot of the approaches that are relying on these data-driven techniques. And I want to highlight one paper that shows that the risks of this for law following AI. This was the opening paper at ICAL in Chicago, and it was a philosophical intervention in a technical debate about judicial opinions as data sources. And it was cautioning against treating these opinions purely as data and perhaps lacking some of that nuance and the richness that we know exists in legal reasoning when undertaken by humans. Okay, so obviously AI innovations prompt questions for the practice, of law. We've already talked about this earlier today in some of the talks. Can and should generative AI be required to demonstrate competence comparable to humans? This is one of the landmark papers on the topic. GPT-4 passes the bar exam. We've got these exams that we have humans taking. Do we require our AI tools to be able to take these, or do we actually require a rethinking of the kind of test that we need our AI tools to pass in order for them to be deployed in practice? So I'll just conclude by pointing to some forthcoming research. Because of the explosion in the application of LLMs in the legal domain, there was a call that was issued by the AI and Law Journal for papers looking at applications and evaluation of large language models in the legal domain. Papers from this special issue of the journal are going to be coming out soon. So that if you're interested in seeing what's been going on in this space and the application of large language models, look out for those papers. Of course, it's a fast-moving field, and things are likely to have moved on since the research was done, but this is really the state of the art being published in the AI and Law Journal. And finally, one thing that I want to mention as well is there are lots of resource centres that are popping up, trying to map what's going on in this space. I sit on the AI Advisory Board for the European Commission for the Efficiency of Justice, and they've put together this resource centre on cyber justice and AI, and they're trying to capture AI tools that are being used in the different stages that they're at, whether they're actually prototype tools or being deployed in practice. This is going to be updated on a continual basis, and these are meant to be resources to help the community see what's going on out there and really allow people to scrutinise whether these are meeting the needs of the legal system. So that's it from me. I just need to thank a number of colleagues with whom I've collaborated on the research that was reported in this talk, and I will hand over to Neel now for a deeper dive on the question of benchmarking for law.
Cool. Hi, everyone. It's wonderful to be here. Thank you so much to the organizers again for doing this. Now, if my math is correct, and in fairness, it often isn't, I think I'm the last thing standing between a room full of extremely jet-lagged people and lunch. So in computer science, we often talk about wanting the agents to be both helpful and harmless, and we talk about our computer scientists being both informative and entertaining. So I will try, but I cannot promise anything. Today, I'm going to be talking about legal AI evaluation, how we think about evaluating and measuring the legal reasoning capabilities of AI. The notion of AI evaluation and legal AI evaluation in specific is something that's already come up today that I think Daniel is talking a bit more about, and I'm willing to bet is going to come up in many other different panels. In talking about this from the computer science perspective, my goal really is to try and provide a little bit of a common vocabulary, a sort of skeleton where we can all get on the same page about what the core issues, core dimensions of legal AI evaluation are. Now, I understand many people, and some people in the room have actually written a lot of papers on legal AI evaluation, and I know this because I've cited them. So I apologize in advance if for some of you this is quite general or feels very repetitive. Awesome. So at a high level, when we talk about evaluation, we're referring to the science of measuring AI behaviors, impacts, and performance. I always analogize it to a science equivalent to what pharmaceutical experts or clinical safety experts think about for clinical trials, what automotive safety experts think about for crash testing. Evaluation goes by many names. It's often known as benchmarking, as validation, as auditing, as red teaming, or even just testing. Computer scientists are good at many things. Consistency about the words they use is not one of them, as I think you have, if not noticed already, will soon notice. Evaluation is traditionally thought about as a subdiscipline of AI or computer science, but in all fairness, it's a quite interdisciplinary process in its modern form, increasingly incorporating concepts from social science, from statistics, and those boundaries are being pushed every day. So I'd like to really talk about three ideas from evaluation and legal AI evaluation that I think are particularly important, both in terms of thinking about legal reasoning capabilities and the larger project of law following AI. The first is the idea of what is it exactly that we're evaluating. Why does this matter? Well, already we've talked about this notion of do we want to put ex-ante regulation? And a sort of core question in regulation is who is the regulation targeting? So in the context of AI, are we doing regulation of frontier model companies that are producing models? Are we doing regulation of system developers that are building systems with these models, or deployers who are using these systems in a specific context? Well, in some sense, how you design this regulation or which type of regulation you want depends on the performance or evaluation information you care about. The second idea is that evaluation operates on a sort of infrastructure and entails a very specific set of technical processes. This matters because these processes and this infrastructure entails a huge amount of discretion. This discretion shapes the kind of information evaluation produces, and thus shapes what your perception of a system, of your perception of AI risks and benefits is. Today, a lot of this discretion is held by computer scientists who make decisions about how evaluation should look. It's not clear that this is what we necessarily want in the status quo, particularly as we think about how to govern these systems, what types of rules we want them to abide by. And the final idea is a sort of, why is legal AI evaluation important? Evaluation produces information. That information are then inputs to various social, political, and governance processes. In some sense, the processes you want to use the evaluation information for should affect how you think about evaluation. Is a particular evaluation supporting the kind of information I need? If I'm getting some evaluation for information for free from somewhere, and it's never really for free, but if I'm getting that information, what types of processes does it enable me to do? How do I think about routing information in this ecosystem where you have evaluation information producers and then information consumers? Awesome. So let's start with the first idea, which is when we're evaluating AI, what exactly is being measured? And so let's take a very stylized example of a legal AI research system. Those of you who are lawyers who may have used all this already in the context of LexisNexis or Westlaw or one of the many other tools, these are basically systems where you can ask a question about the law, whether it's case law, statutes, regulations. These systems use advanced frontier models like GPT-4 or possibly 5, depending on how the next 24 hours goes. They combine these models with databases storing legal information. So you might have a database of case law, of rules, of statutes, or regulations. And they use various different AI systems like retrieval systems or search engines to sort of fuse all of this. So when we think about evaluation, the first thing we can ask is, does a human using this system give us the right answer? So they have a question, they go to the system, they get a response from the system, and then they apply some editing to that response, or maybe they choose to ignore the response. And we can evaluate how well is the final answer that the human gives us correct. The second thing we can ask is, does the system in isolation give us the correct answer? So if we just give a query to the system and we get a response from this system, is that response correct? Does it contain the things we want it to? Is it making up case law? Is it asserting things that are factually incorrect? This is what we might call evaluation of a tool or of an app. And the final thing we can do is we can actually go to the underlying model in the system, so GPT-4, Claude, whatever it is, and just give the query to that model and ask, is this model giving the response by itself using knowledge only stored in its weights or parameters? So forget about the database, forget about all of these other bells and whistles. I'm just giving text to a model and I'm getting text back, and I want to know what the quality of that text is. The key point is that these are three fundamentally different kinds of evaluation. All are important, and when we think about an evaluation ecosystem, we want information on all three of these levels, but they all serve very different purposes. When you're evaluating a human plus AI system, this is helpful if you're trying to figure out, well, do law firms or lawyers who use AI, are they more effective than their peers who don't? Are they subject or prone to certain types of errors? Are they producing better work products? When we think about tools or systems and evaluations of tools or systems, we're ignoring the human component, but this is still useful information if we're trying to think, is one system better than another system? What is how do we think about the relative capabilities of these systems? How do we think about the risks associated with these systems? And when we think about evaluation at the model layer of individual models, this is quite useful for system developers who have a choice to make. I'm building a legal research tool. There are literally thousands of large language models out there that I can use. How do I know that I'm using the best one? So for instance, we don't know but it's generally believed that across the many models you can download on Hugging Face or for any of these commercial API developers, Some of these models are probably much better at contract law than others. Some of them are much better than securities or others. There's not necessarily one single model that dominates. So information at this model level serves a very valuable purpose. Awesome. So the second idea I'd like to talk about is the infrastructure or process of evaluation. So when we talk about conducting an evaluation, we typically do it in the following highly stylized process. So we start with a set of inputs. We give our inputs to the thing we're evaluating, and remember, this can be a human plus AI, this can just be a tool, or this can just be a model, and we get a bunch of outputs. And then we look at the outputs, and we assess whether they're correct using a variety of application or domain-specific metrics about, is this citing the right sources, is the quality of the writing good, et cetera, et cetera. We often call these metrics. To give an example, if we were evaluating a human plus AI legal research tool, we'd have a bunch of queries, we'd get a bunch of research responses, we might grade the responses based on how accurate they are or how helpful they are. If we had a lease review tool that helped us assess whether a particular lease was enforceable, we'd feed in a bunch of leases, we might get a bunch of classifications out in response of enforceable, unenforceable, and we'd ask, is the system's prediction about enforceability correct according to our legal judgment? And if we were evaluating GPT-5 on a bunch of law school exams, we might give it these exams, and then we get a bunch of grades. And you'll notice all of these are passing grades, and I'm not going to make a comment on that. So this is what the process of evaluation looks like. The sort of core infrastructure underlying this evaluation process is what we call a benchmark. Now this gets very confusing again because computer scientists mean something very specific when they say benchmark, and the rest of the world means something else entirely, most often. So apologies on behalf of my community. There are typically two forms of benchmarks that we see in legal AI. The first is when there's a single objective correct answer to what we're evaluating. The least example is a best example of this because our output space is constrained, right? We think about the system as only producing enforceable or unenforceable. Whether you want to design a system that does something else is a separate issue, which we'll cabin for now. But in these cases, we construct a benchmark, which is you can essentially just think of an Excel spreadsheet. One column is the inputs, one column is the outputs we want. These benchmarks are expensive to produce, but once you have produced them, they are trivial to run, and they are very, very cheap to produce successive evaluations on. The second kind of benchmark is a very different story. In this benchmark, we typically use for generative applications where there are multiple possible correct answers. So we have our inputs, and then for each input, we typically have something that looks like a rubric telling us what a good answer entails. To evaluate systems on these benchmarks, you need a human, most often, to manually look at every system's output and grade it across this rubric. This means that evaluation, every time you perform it, is quite expensive. If I've evaluated 100 systems and I want to evaluate a 101st system, I pay 100th additional cost. In the first case, if I've evaluated 100 systems on a benchmark and I want to evaluate a 101st system, I get that evaluation basically for free because I'm just doing automatic comparisons. Benchmarks typically have several requirements that we think about as needing to be good, and these matter a lot for legal AI. So the first thing we care about are the inputs representative of real-world distributions. If I'm building a lease enforcement tool, I want to benchmark on actual leases. I don't want to benchmark on fake leases or purely model leases or only leases from one particular building complex. The second is how subjective is this output assessment, and this has been quite a challenging problem in legal AI evaluation where you have an issue that experts can reasonably differ. If experts are reasonably differing on a binary classification judgment, it's difficult to tell when your system is correct or wrong. The third idea, and this is also a problem, especially when we talk about American legal AI, is what jurisdiction the benchmark is representing. If you're talking about federal law, that's one thing. But if you're talking about a legal task where the law can vary on a county-by-county basis, you now need to build a separate benchmark for every county. So our favorite friend, federalism, in a different version, once again strikes again. This matters a lot when we're talking about legal aid applications where you might have this county-by-county variation. Another issue is what we think about as the temporal stability of a benchmark. So the law can change. Every time the law changes, your benchmark or parts of it might be invalidated. People's behavior with the legal AI system can also change. Suppose we had a sort of or a great example might be is we generally believe that people are asking ChatGPT a lot of legal AI questions. I'm sure OpenAI has these numbers, but the types of legal AI questions they were asking before and after the LA wildfires are probably very different because the modal legal issue before and after the wildfires changed. These sort of environmental changes affect what we need to evaluate for. And finally, another issue here is what is the risk of leakage or gaming? So to what extent can you cheat on benchmarks by accidentally training models on them itself? Great, so in the last minute, I'd just like to focus on why is legal AI evaluation important. And there are basically 4 general reasons we think of it as being important. The first is that evaluation is essential for innovation. AI development is, for lack of a better terms, can often be an exercise in hill climbing. Evaluations give you better information on the differences between AI systems and the relative value of technical improvements. If you have better evaluation information, you're usually able to design better AI systems. It also matters for responsible adoption. If you want to ensure someone is using an AI system well, then you want to give them information about how to use that AI system or what the potential failure modes they should avoid are. In a similar way, as we try to think about how we educate students or educate individuals on the use of AI, a lot of this needs to be informed by evaluation information, again, going to the idea of how they should use these systems. And the final idea is that this matters a lot when we talk about the regulation of legal AI systems. The lifeblood of regulation is information. If you have better information about the performance of a system, you can craft more detailed, more granular, more specific rules. I think a very useful case illustration of the deficit of information about legal AI is the number of courts which have essentially created disclosure requirements which are tell us if you're using AI or not, which a number of people have pointed out isn't actually helpful. If we had more and better legal AI information, you might be able to imagine more tailored disclosure requirements. Awesome, thank you so much.